Okay, in this video, I am going to illustrate what are the six trigonometric ratios. Okay, in defining the six trigonometric ratios, we are going to consider a right triangle. Okay, when we see right triangle, one of the measure of the angles is 90 degrees. Okay, so here angle C is a right angle with this symbol. This symbol is a perpendicular, symbol of perpendicular. So these two lines or segment AC and BC are perpendicular. So they form a right angle. So the measure of this is 90 degrees. Okay, let us consider that the measure of AB is C and the measure of BC is A. The measure of AC is, let's say, B. Okay, so in a right triangle, the opposite side of a right angle is called hypotenuse. So this is our hypotenuse. Hypotenuse is the longest side of a right triangle. And A and B are called legs. A and B are called legs. Okay? So let us now define what is sine. Sine, but before we define what is sine, let us determine first a reference angle. So let us say that the measure of angle B is theta, where theta is greater than 0 but less than 90 degrees. Okay? So let theta be the measure of angle B, where theta is greater than 0 but less than 90. Okay, so when we say sine theta, sine is opposite over hypotenuse. Okay? In this figure, the opposite of theta is B. So B is the opposite side of this angle theta. And A is called the adjacent side of theta. It's called adjacent side. So again, sine theta is opposite side of the given angle theta over hypotenuse. So in this figure, the opposite side of theta is B. So we can say that sine theta is B over hypotenuse C. Okay? How about for cosine theta? Cos is the abbreviation of cosine. So we have cosine theta. Cosine is adjacent over hypotenuse. So adjacent side over hypotenuse. Reference angle here is theta, and the adjacent side of theta is A. So therefore, A over the hypotenuse C. That is cosine theta. Okay? For tangent, tan is the abbreviation of tangent. So tangent theta is opposite over adjacent. Tangent theta is opposite over adjacent. So theta is our angle. So the opposite side of theta is B and the adjacent side of theta is A. So tangent theta in this figure is B over A. Okay. So these are the three primary trigonometric ratios: the sine, the cosine, and the tangent. If you will forget this ratio, just remember this. So, ka, toa. So stands for sine, opposite, hypotenuse. Ka, cosine, adjacent, hypotenuse. Toa, tangent, opposite, adjacent. Okay? Okay, for the remaining three trigonometric ratios, these are the secondary trigonometric ratios. Say cotangent. Cot is the abbreviation of cotangent. So cotangent is the reciprocal of tangent. We know that tangent is opposite over adjacent. Therefore, cotangent is adjacent side over opposite side. Okay, this reciprocal of tangent, because tangent is opposite over adjacent, cotangent is adjacent over opposite. So in this figure, cotangent theta is A over B. A divides B. That's cotangent. Okay? So cosecant theta, or cosecant, is the reciprocal of sine. So cosecant theta in this figure, CEC is the abbreviation of cosecant. Cosecant is hypotenuse over the opposite side. Okay? So here cosecant theta will be C over B. That is cosecant. For secant theta, secant is the reciprocal of cosine, and the abbreviation of secant is sec. So secant theta is hypotenuse over adjacent. So opposite of hypotenuse is C, over the adjacent of theta is A. Okay? So, these are the 6 trigonometric ratios. Okay? To summarize, sine, if we are asked to find sine theta, or sine of angle theta, will be B over C, opposite side over hypotenuse. And for cosine theta is adjacent over hypotenuse, that's A over C. And for tangent theta, we have opposite over adjacent, B over A. And cosecant theta is the reciprocal of sine theta, so C over B. And secant theta is the reciprocal of cosine theta, we have C over A. And tangent theta is the reciprocal of cotangent theta, it's A over B. So these are the 6 trigonometric ratios, and these are only applicable if we have a right triangle.